Hello everyone. Today I will give you a lecture on a topic that is the methods for the enhancement of the bioavailability. I mean that what are the different methods which are used for the enhancement of bioavailability. So now let's take a start. So the enhancement of drug solubility or dissolution rate, which is one of the major contributing factor through which you can enhance the bioavailability of any products of any drug. So there are two processes which are used for the enhancement of drug bioavailability. And so in order to enhance the bioavailability, you should improve or increase the drug solubility and dissolution rate. So the first one is micronization. What is micronization? So micronization is the process which is involved by reducing the size of the solid drug particle to 1 to 10 microns. And micronization, the spray drying or by use of the air iteration methods, fluid energy or jet mel is used. This process is also called micromellings. So for example, this type of process they are usually performed for the X-gracefulvins, which is antifungal agents, and the second one is steroids. The second one is nanonization. Nanonization is another process which is used for the enhancement of drug solubility dissolution to increase the bioavailability of drug. Nanonization is the process by which the powder is converted to the nanocrystals of sizes 200 to 600 nanometer. So the classical such as amphotericin B, which is also one of the best antifungal agents. As we know that nanocrystals on dispersion in a liquid, for example, water yield nano suspension. The nanoparticles are prepared for millings or by homogenization and suitable solvent. So all these data have been taken from the latest research papers. Look at the molecular encapsulation with cyclodextrin. So here the beta and gamma cyclodextrins, they are bucket shaped oligosaccharide produced from the starch. They have the tendency to form the molecular inclusion complexes with the hydrophobic drugs, which get entrapped into within the hydrophobic cavity, with the outside of the drug molecule being relatively hydrophilic. The molecularly encapsulated drug has greatly improved the aqueous solubility and dissolution rate. For example, thiazide diuretics and barbiturates. You can see here, and this molecular encapsulations and this technique you can see here, this is carboxylic acid and this one is hydrophilic exterior water loving, and this is hydrophobic interior, while this one is the cavity for encapsulating the hydrophobic drug. So how we can encapsulate the hydrophobic drug in this cavity, and this one is the entrapped aspirin molecule. You can see this is the entrapped aspirin molecules. This is the basic structure activity relationship. In solid solution, binary system comprising of the solid solute molecularly dispersed in a solid solvent. The two compartments crystallize together in homogeneous one-phase system. Solid solutions are also called molecular dispersion or mixed crystal. It can be prepared by fusion method. Physical mixture of solute and solvent are melted together, followed by rapid solidification. Ends, they are also called melts. For example, gracefulvin succinic acid. You can see here in both the diagram, this is substitutional solid solution and this one is interstitial solid solution. And you can see the clear difference. Here this one is crystal lattice of the carrier molecule. This is also the crystal lattice of the carrier molecule, and this one is, both of them they are empty, and this is the interstitial solid solution, while this one is substitutional solid solution. So, how we can differentiate between these two? So, here is also the drug molecule, that is also, you can say, that is also present in the interstitial area. Here this is the solid solution, and this solid solution you can see here the interstitial area, and with the drug molecule that is embedded here, while in this case the drug molecule, they are encapsulated or embedded here. In case of substitutional solid solution, the drug molecule, they are embedded, and you can clearly see there is no any interstitial spaces, but they are directly embedded, or they are encapsulated, or they are sandwiched in the solid solution, while in this case you can see these are the interstitial spaces. So, these drug molecule can be embedded or they can be sandwiched in these interstitial spaces of the solid solution, because both are solid solution, but the difference is only here in the encapsulation of the drug molecules. If the diameter of the solute molecule is less than 60% of the diameter of the solvent molecules, or its volume less than 20% of the solvent molecule, then the solute molecule can be accommodated with the intermolecular spaces of the solvent molecule. So, the classical example is digoxin, PAG polyethylene glycol 6000. So, you know digitoxin is a this is the drug which is used in the treatment of congestive heart failure, CHF. So, this point is clear that if the diameter of the solute molecule is, you can see here, these are the different molecules. So, if the diameter of the solute molecule, they are less than 60% of the diameter of this solvent molecule, or its volume is less than 20% of the solvent molecule, then the solute molecule, it will must be accumulated or accommodated within the intermolecular spaces of the solvent molecule. For example, digitoxin PG 6000. Such homogeneous, transparent, brittle system is also called glass solution. Carrier that form the glassy structure are citric acid, urea, PVP, and PEG, and sugar such as dextrose and sucrose, etc. This system, when exposed to water, the soluble carrier dissolve rapidly, leaving the insoluble drug in the state of microcrystalline dispersion or at molecular level. What is eutectic mixture? Eutectic mixture, pharmaceutically, it can be defined as, so intimately the blended physical mixture of two crystalline components that are prepared by fusion method is called eutectic mixtures. So, in eutectic mixture, there is a blended physical mixtures when there are two crystalline components, and these two crystalline components are prepared by the fusion methods. Eutectic melts differ from the solid solution in that the fused melt of the solute solvent show the complete miscibility, but the negligible solid solubility. When this eutectic mixture is exposed to water, the soluble carrier dissolve and leaving the drug in a microcrystalline state which solubilize rapidly. Solid dispersion can be defined as, solid dispersion is prepared by solvent or co-precipitation method, and dispersions are called as co-evaporates or co-precipitates. So, the solute and the solid carriers solvents are dissolved in a common volatile liquid solvent. The liquid solvent is removed by evaporation under reduced pressure or by freeze drying, which results in amorphous precipitation of solute in a crystalline carrier. For example, the amorphous sulfathiazole and crystalline urea. But in solid solution or eutectics, the drug is actually precipitated in crystalline form in case of eutectic mixture, because we have already discussed. Carrier are used they are same as per eutectic or solid solution with glassy materials. The dispersion formed or called glass dispersion or glass suspension. The method is suitable for thermolabile substances or heat sensitive substances. Since the carrier is hydrophilic, so water loving, and the drug is hydrophobic, the drug will be hydrophobic while the carrier will be hydrophilic. So it is difficult to find a common solvent to dissolve both the components. I think there is no solvent that we can dissolve both the hydrophilic and hydrophobic portion. Now there are some disadvantages. Disadvantages are higher cost of the processing, so it need a very high cost and use of large quantities of solvent is required, and difficulty and complete removal of solvent. The product is often soft, waxy, and possesses poor compressibility and flowability. This is one of the discrepancies, that the products which are obtained, these products will be soft, waxy in nature, and it will possess poor compressibility and flowability. Since the carrier is hydrophilic and the drug is hydrophobic, so it is difficult to find a common solvent to dissolve both. So the product is often soft, waxy, and with poor compressibility and flowability. Now come toward the supercritical fluid recrystallizations. So in case of supercritical fluid recrystallization, there should be nanosizing and solubilization technology. The supercritical fluids, for example, the carbon dioxides, they are the carbon dioxide, and supercritical fluid, these are the fluid at the critical temperature and critical pressure, which can assume the properties of both a liquid and a gas. So at near the critical temperature, the supercritical fluid recrystallization, they are highly compressibles with altered density and the mass transport characteristics of a fluid. Drug particles, they are solubilized within supercritical fluid recrystallization and recrystallized at greatly reduced particle size. So this lecture was correlated with bioequivalent study, how you will conduct a bioequivalent studies. So in experiments, we are always going to conduct different studies. So actually I have explained the overall methods, that how we will conduct different experimental studies, and then the pharmaceutical terms which are related with it. And I have already explained the different methods which are used for the enhancement of bioavailability. Definitely, if you want to enhance the bioavailability of the drug, so first of all you will have to check the drug solubility profile and the dissolution rate. So that is directly correlated with it. So in this lecture I explained the micronization and nanonization process, and as well as the molecular encapsulation with cyclodextrins, solid dispersions, eutectic mixture, solid dispersions and its advantages, disadvantages, and supercritical fluid recrystallization. So I am very thankful to all of my viewers who are watching my lectures on regular basis. So if you have any question regarding my lecture, so I am always available for any kind of services. If you didn't subscribe my channel, so kindly subscribe my channel and press the bell icon for my upcoming lecture. Thank you so much to all of you.